Happy Sunday everyone, we're back with another video, this time on decoding popular bridges using event logs. I've gotten good feedback that my previous video on Uniswap v2, decoding Uniswap v2 with event logs, and so I'm trying to do the same thing, this time with bridges. Now, I'll be looking at just random bridges on base, and I think most of these bridges already have proper decoded event logs, but in the event where there is a bridge that you want to decode, or there is a chain that you want to decode where it's not, or the bridge is not available, bridge decoded data is not available, how do you decode it? Well, in this video I'll show you how to do that, right? So let's first look at some, what is the most popular bridge on base. I believe it is platform. Yeah. Okay, let's see. Alright, so it looks like it's across and also circle CCTP. Sure, why not? So let's look at those. And so I'm trying to get some random transactions. Let's just start with across. Just gonna copy this. Names platform equals to across v3. And then open up base scan. So unlike Uniswap, unlike Dexus, there is no standard way of creating a bridge, and so different bridges have different ways of making the bridge, and so there's different types of data that's being emitted. However, I think there are some similar themes across different bridges. For example, there has to be some sort of destination ID that denotes the chain that it is bridged to. Destination receiver, what is the token that's being bridged, the amount, right? All those are pretty standard and the same across all of the bridges. And so yeah, let's take this first transaction over here. Okay, so looks like this is a very recent bridge from the Across Protocol 3 hours ago, and looks like they are depositing WEF. Okay, cool. Okay, so I guess the good thing here is that all this is sort of decoded, and so you can can already get the data very easily. So let's try to do this manually, right? So I'm gonna comment this out and call this across tree, and let's start our manual decoding. So select from base core event logs. And transaction hash is this. Now, I guess the first question is, which contract address should you use? In this case, it's quite straightforward because there's only one. But I would first try to look up the documentation to see if the Across Protocol has a documentation that lists their contracts, and their contract would be, you want to use their contract is in the contract address filter. Make sure to make it in lowercase, and as usual, the important thing about using event logs table is you need two filters, or two important filters: contract address and also topic 0. So the combination of contract address and topic 0 ensures that you are exactly looking at this particular event and not other events. Okay, so topic 0 you can find here, so I'm going to copy this and paste it here. Okay, and we need our usual stuff like topic 1, right? Topic 2, topic 3, and of course our data. And I would of course need my handy, where is this one? There you go. So I always have this in my queries, where what it does is it splits up whatever column I want into a specific length. So in this case, I'm taking the data column, start from the third character onwards, because there is a OX appended in the front, and then chunks it up into 64 characters long, because Ethereum data is in chunks of 32 bytes, and 1 byte is 2 characters long. So that's why it's 64 characters. And I think that's it. Let's go ahead and run this. Now, another thing I want to say is that if you don't know, if the data is not decoded, you can sort of just roughly guess like what data corresponds to what by looking at the overview page, right? Because you would know the address that sent the amount, you know what amount is it, you know how much is the amount, and so you can sort of just guess what that field would represent, right? So that's the worst case scenario. But of course here we have a contract that is verified, and so we know exactly all the parameters that goes into this particular event. Okay, so that's fund deposited. It's the fund deposited event, which corresponds to this topic 0. Okay, so now we've got our topic 1, 2, 3, and now it's time to decode this, right? So how to read this thing that Etherscan has? Here's how. So if it tells you, if it states index topic 1 or index topic 2 or index topic 3, that refers to the topic itself. Okay, so in event logs, we are given 2 sort of categories of data to work with. We have topics and we have data, right? The raw version of data looks like this, which is what we have over here, right? Just that we chunk it up into chunks of 32 bytes. And so yeah, so there's 2 categories of data. There's topics and also there's data. And so how to read this is, if the data, if that parameter exists in topic, it will tell you exactly where in the topic it exists in. So for example, index topic 1, okay, refers to topic 1. Okay, index topic 1 refers to topic 1. Index topic 2 refers to index topic 2. And then lastly, index topic 3 refers to index topic 3. Okay, and the word in green represents the data type. In this case, index topic 1 is of data type unsigned integer. It's an unsigned integer, which means it's an integer with no negative values. It's a positive value. Okay, and the name of the parameter is called destination chain ID. And so index topic 1 is destination chain ID, and we know that it's an unsigned integer, which would tell us how do we treat the data, right? And because it's an integer, we just need to convert it from hex to int. So let's look at where we have it. Index topic 1. Topic 1 is an integer, so convert this to integer. So we should just be livequery.utils.udf hex to int as destination chain ID. Right, simple as that. Okay, what's next? We have index topic 2, which is another unsigned integer. This time it's called deposit ID. So we do the same treatment. Convert this from hex to int. as deposit ID. So some sort of identifier that for this deposit. And then index topic 3 is a bytes 32 depositor. Now a lot of people ask me, like, how do you decode bytes 32? Well, there's nothing to decode, right? Bytes 32 is simply just means it fills up the entire length of the topic or the data, right, in one line, because in one line there'll always be 32 bytes, and so by specifying it as bytes 32, you're sort of making use of the whole line. Now why is this done, especially for bridges? It's because imagine you are bridging a token to another chain, like for example base to, let's say, Solana, right? And Solana might have a different number of characters for its address. Okay, for EVMs it's always 40, but for Solana maybe it's more than 40, right? And so just to keep things consistent and standardized, you would often see addresses, especially like receiving addresses, in the form of bytes 32. And so what you need to do is just to cut out the first 25 characters or 24 characters, and then use the remaining 40 characters as your address. If that is, of course, if the chain is an EVM chain, right? So that is how you treat this thing. But because I don't know, I don't know what exactly is this chain ID yet. I don't know what 10 represents. I'm just gonna leave this as it is. So I'm leaving topic 3 as it is, and I'm just calling it as depositor raw. So this would be my raw data that I will need to sort of clean up later on once I figure out, which chain ID corresponds to EVMs. Okay, all right, let's move on. So that's all of the topics done. There's only 4 topics. The first one being the identifier. So there's only 3 topics to decode. Now let's move on to the first one. How do we know what is the first thing in the data? Well, let's go back to this part here. The first thing it says is input token, and the order of which this is arranged corresponds to the order in which it appears in data. With the exception, of course, if there's an index topic, this refers to the topics. So the first thing in data will be input token, and it is a bytes 32. So input token is the first one, so I'm just going to call it input token. So it's the first one, so that means it's the first element in the array as input token raw. Output token, part 1 is output token raw. Now before we proceed, because we're on base, and we kind of know that if it's on base is an EVM, the input token has to be an EVM address, right? You're sending a token from base, and so the input token in base is an EVM address. And so treat this as an EVM address, which means, right, this first part here, since this is padded 0 and to fill 32 bytes, I'm just going to take out the first 24 characters, so I can use the remaining 40 characters as my address. So I can do something like substring 25, and then add an OX in front, a 0x, and I think that's it. So we just get the first element of data, cut out the first 25 characters or 24 characters, and then append the OX in front, and we should get our input token. There you go, input token this. Let's check. This would be, yep, WEF on base. So that's right. Okay, what's next? The next thing to decode is output token. Obviously, we don't know what this could be, right? This could be a token on Solana, so we don't exactly know how to treat it yet. But we can move on, right? The next one will be input token, and it's an unsigned integer, which means convert from hex to int. So this will be part 2, and just copy my hex to int function. Simple as that. As input amount raw. Now I leave it raw because I still don't know what is the it's not corrected to the right decimal places, but I know it's converted to an integer, so I'm gonna cast as int just in case, right? Okay, what's next? The next one, output amount. So copy this thing. So let's make sure it's a 0, 1, 2, 3. Oops, okay. Yeah, so part 1, part 2, part 2, part 3, and this will be output amount raw, okay. And index topic 1, so we skip this because we already decoded index topic. Next topic. The next one will be, quote timestamp. So same thing, because it's an integer, convert this to integer. Now the cool thing about after we convert this number, right? Quote timestamp. I'll show you guys what I mean. So let's just first run this query. And while that runs, okay, never mind. Okay, quote timestamp, right? This timestamp is timestamp in Unix. So if you look at Unix to timestamp, right, you sort of convert this number into a actual timestamp. And so to do that, Snowflake, oh my god, what's happening? Snowflake has a function called toTimestamp, and you can just use that. And let me run this query now with the toTimestamp function, and we will get the actual timestamp of when this is quoted. So it's taking some time to run. Let's Alright, while that runs, we can move on. The next one is the exact same thing, fill dateline, which is another timestamp. So we can just copy this thing honestly and change this to 5, and this will be fill timestamp, or fill dateline rather. Fill dateline timestamp. Okay, let's check. Yeah, there you go. Quote timestamp 6 April 9:30, and the timestamp is, yeah. So that means when the person attempts to make a bridging transaction, this is when the quote was given, and then this is when the actual transaction was sort of filled. Okay. Okay, now what's next is exclusivity dateline. I'm not sure what this is. But then the next one will be recipient. And I think we would want recipient because we have the depositor. So recipient would then be, so 6 would be, 6 would be exclusivity dateline. And so 7 would be the recipient. Okay, so part 7 is my recipient, and because it's an address, we just apply the address treatment, which is substring 25, and then add a 0x in front as recipient. Oh, hang on, I don't know what is the destination, so I cannot just, I have to just leave it as part 7 as recipient raw, something like this. So I'll run this query, and now is my now is where I sort of clean up the data, because I know that I know the destination chain ID, and I know that if it's an EVM, I can apply some rules. And so now will be the time to look up sort of like across protocol docs and look for when it has some sort of mention about the chain ID. So right off the bat, I see a supported chains. Oh wow, cool. Okay, so it looks like all these are the EVM chain IDs. Yeah, I think so. I actually don't know if they are like non-EVM chains that it supports. Lab 0, is this EVM? Oh, it is EVM, okay. Interesting. Okay, well, if everything is EVM, then I guess we can just sort of apply the same rules, right? So in here we sort of leave the depositor as raw, but if everything that across supports is EVM and only EVM, then we can just apply it to everywhere. Okay, so again, do your due diligence, and this is not the case for all bridges, but it looks like it is the case for across. And so I'm going to apply the same treatment here, which is depositor is an address, so substring topic 27 and then 0x as depositor. For topics we need 27 because there's an extra 0x in the front. Okay, what else? Input token raw. I can copy this for output token raw, which makes things a lot simpler. Wait, what is this? This is wrong. Oh, sorry, this is the token, this is the amount, I see. Okay, this is correct then. So output token, input token, this is the amount, this is the amount. And then recipient would just be substring 25 at a 0x in front. All right, let's run this query and see what we get. All right, cool. So we have destination ID 10, and based on the logs, destination ID 10 is optimism. Okay, so this is a bridging transaction from base to optimism, and the depositor is 459. Let's look at, yeah, so it looks like it's the address that initiated the transaction, the bridging transaction, right? 459. And they bridge the WEF token, which should appear as the same contract address in Optimism because they are all part of the superchain, so it's the same contract address. Input amount is, this needs to be corrected by the right number of decimal places, right, using the prices table or the asset metadata table, but this is 0.01 ETH. And in the receiving chain, the receiver would receive this amount, so slightly less due to slippage of fees, right? And then we have our code timestamp. What is the deadline to fill this bridging thing? And then of course our recipient, which seems to be the same address as the address who initiated the transaction. Yeah, I think that's all. That's all the information that you need. So how I would go about doing the rest of this is look for other transaction hash examples. Look for not just this date, right? And try to see if there are more destination chain IDs than what it is listed here, right? And so that would help you determine if you need more special treatment to treat the depositor, the recipient, so on and so forth, right? Just one example. So let's say we know chain IDs 1 and 10 are EVM. You can do something like if destination chain ID in 1 to 10, right? Right, if destination ID is then do this treatment, which is the EVM treatment. Else, just use part 7 as the address, right? Something like this, right? This is how you would treat the EVM versus non-EVM addresses. Okay, so I think that's all. Again, event logs use the contract address and topic 0 to filter for the proper event. And yeah, let me know if this is helpful. Let me know what other topics you'd like to learn or see or watch. And thanks for watching. See you on the next one. Bye.